Hi, this is Yogesh Landge, and in this video, we will see a numerical on convection. So the statement that is to be read here, it is a 1.2 kg of liquid water initially at 15 degrees Celsius is to be heated to 95 degrees Celsius in a teapot equipped with a 1200 watt electrical heating elements inside. The teapot is 0.5 kg and has an average specific heat of 0.7 kJ per kg degree Celsius. Taking the specific heat of the water to be 4.18 kJ per kg degree Celsius and disregarding any heat loss from the teapot. Uh, Calculate or determine how long it will take a water to be heated. So here we want to calculate what is the time period required to heat that conditions. So let's see, first write down the data which is being mentioned here, and the data are, it is, they are given water quantity. So let's consider it is have a teapot. So it is have a teapot, okay, with the 1.2 kg of water to be there, and teapot is equipped with a heater. There is a heating element with a capacity of 1200 watt, okay, and the teapot is 0.5 kg and has the average specific heat. So if as this teapot, this contains the mass which is 0.5 kg. It means the liquid, that is water, pour into the teapot having the quantity 1.2 kg, and the itself the pot is, which is the empty one, let's consider, and for that one the mass is 0.5 kg. The specific heat of the teapot as well as the specific heat of the water be there is given disregarding the heat losses from the teapot. So we consider there is no heat losses from the teapot, okay. And for that we want to know what is the time that is to be required by this electrical heater, which having the power is 1200 watt, and we have to raise the temperature from 15 degrees Celsius to a 95 degree. It means it having a liquid of 1.2 kg which is poured into the pot, and this pot itself having the 0.5 kg, okay. We have the heater inside it with a 200 watt capacity, and the temperature, initial temperature of the, say, the surrounding or say water, or this one is 15 degrees Celsius, and we have to heat it up to the 95 degrees Celsius. So what is the time required for these cases? What is the time required for this one? Say the temperature rise from 15 degrees Celsius to the 95 degrees Celsius. So this time period that we need to calculate with the power is given this one and other conditions. So here simply if we write a data which is be given here. So what is the data is given? Let's consider the mass of water which is 1.2 kg. Then they give the initial temperature T1 15 degrees Celsius, and the final temperature that is to be reached, it is given 95 degree Celsius. The power of heater that we noted by the P, which is a 1200 watt, okay. And on the other side again it is mentioned that the teapot. So these are the data from the water one. Say for the teapot data, in that one they mention the teapot. Let's consider the mass of teapot is 0.5 kg as given, and the specific heat of the teapot that is mentioned by CPT, which is 0.7 kilojoule per kg per degree Celsius. Also the specific heat of the water is mentioned here, which is B of 4.18 kilojoule per kg per degree Celsius. Okay. Now, with the help of the given data and all other conditions, we try to get what is the time required to reach from 15 degrees Celsius to the 95 degree Celsius. So let's step by step we will solve this numerical and try to get what is the value of it. So here, so there are the four stages for this one to get the okay to get the answer. The first stage we try to get find the heat energy required for the heat the water. So how much energy is required to heat the water? Because ultimately we have a pot. In that pot we have water, and what again the heat required for the pot, because obviously heat absorbed by this pot as well as the heat absorbed by the water and the power which is given by the heater. So first try to get what is the heat energy required to heat the water. Then second case is the find the energy required to heat the teapot also. And the lastly the addition of these two, okay, that will give the total heat energy required, and total energy required which is being noted by the Q, and the power that we supply by the heater, that is P. And on the basis of this relation we try to know with the help of this formula, say the time required to heat, then it is Q, the amount of heat that is required and an amount of heat that is be supplied. It will give the answer as the the quantity of the time required to heat the water. So let's first try to get the value of the first case, which is the energy required to heat the water. And for that one we can have a formula, and the formula is that, what is the formula? So first we try to find heat energy required to heat the water, the water. Okay, so what is the formula for that? So we write a formula, Q is equals to the mCp delta T. So m is nothing but the mass of the water, Cp is the specific heat of the water, and the delta T is the temperature difference. So temperature difference is what? It is reach up to the 95 degree, and initial temperature is 50 degrees. So delta T is nothing but it is delta T is what? It is T2 minus T1. Okay, what is T2? T2 is, sorry, it is T1. T2 is 95 and T1 is 15. So initial temperature and final temperatures. Okay, so let's put it the values of it in that. So once we put it the value, the mass of the water, which is 1.2 into specific heat, is given the here. The specific heat is how much? 4.18. Okay, so 4.18. So we can write this value be here 4.18, okay, which is in kilojoule per kg. So let's convert into the joule per kg degree Celsius. So we just have a multiplication of this one, 4.18 into the 1000, that will give in the joule per kg. Okay, so just put it that all these values in that, and so we can put it that values and say we can write as 1.2 into the 1000, which is be converted into the joule per kg, into the specific heat is what? It is 4.18, okay, into the temperature difference, which is 95 minus 15, which is around the 80. Okay, so once we do these calculations we got the answer. So Q value is 402, around 402 point some points, it is 0.05, and into the 1000. Okay, so we just multiply this one, and then we just multiply by 1000, so it comes into the joule per kg degree Celsius. Or even you can put it itself in a, if you don't want to multiply, then let's consider kilojoule per kg. So let's see, we do it with the kilojoule per kg degree Celsius. So there is no conversion for this term. Next, so once we solve this one, so what is the answer for this one? It is 402 kilojoule per kg per degree Celsius. Sorry, not Celsius one, it is kilojoule per kg. So this is the Q value. Okay. Now next step, it is to get the value of the heat required for the teapot. Again, the same formula that we use as it is. So we can write as, now for we calculating for the teapot. So we can write for the teapot how much heat required for teapot. So again we use the same formula. The Q for the teapot is equals to the mass of the teapot into the specific heat of the teapot into the temperature difference. So here mass of teapot is how much? It is, so we found that a mass of teapot is zero point 0.5. So as mentioned, mass of teapot is zero point 0.5. Okay. The specific is heat is also given, and the specific heat is given in the numerical, which is zero point 0.7. So zero point 0.7 into the temperature difference, which is again 95 minus 15. Okay, so once we do the calculation for this one, we got the value of qt, that is the heat required for the teapot, and the value is around, we got it is around 28 kilojoule. So around 28 kilojoule. So we got the value of qt and the value of q. The next steps which is we mentioned there, what is the next step? So we got these values, this one and this one. Now for the next step, third one, the total heat energy. So total heat energy is what? The amount of heat required for the water, amount of heat required to teapot. It means how much heat is absorbed by the teapot as well as how much heat is absorbed by the water. That will be, the formula is total amount of heat required. So it is amount of heat for the water, amount of heat for the teapot. So with the help of this formula, we get the total heat required. So we write it is as the total heat required. The second step, total the total heat required, or the total energy, sorry, the total energy required. How we calculate that is, again the formula is total is equals, or we can write it is a Q, so there is no confusion. Okay, Q is equal to amount of heat required for water, amount of heat required for the teapot. So we calculate the KW value, sorry, QW value, which is around 402, plus this is 28. So total amount of heat that is required is 430. So around 430 and certain points is there, okay, in kilojoule. So this is the third step. Now the fourth step is what? We need to calculate the time. So what is the time required? So we want to know what is the time required to reach a temperature from 15 degrees Celsius to the 95 degrees Celsius with the given conditions, and we try to get a value of Q is required, which is 430 kilojoule. So this much amount of heat that is required, and we have the power. How much power of heater? The power of heater is 1200 watt. So we have a formula for that one. So the formula is like that: the T, the time required, is equals to the, the total energy required, the total energy required Okay, the power of heating element. The power of heating element. It is heater. The power of heater. Total energy is required how much? It is 430, and we just converted that into the kilojoule. Okay, which is in a kilojoule, right? And sorry, which is in a kilojoule, and we have the power which is in a watt. So we just convert this 430 kilojoule into the joule first. 4300 multiply by 1000, which is in joule. So it is very easy for us to do the calculations and all. Or vice versa also you can do, that is you just have convert this into the kilowatt, because ultimately we have this arrangement: watt is equals to the joule per second, or kilowatt equals to the kilojoule per second. So either we go for this case, or this case it is one and the same. So if we say we first converted this 430 kilojoule into the joule, so 430 multiplied by 1000 upon the kilowatt is sorry, it is in a watt, so we can say 1200 watt. So this much is the time required to heat. So if we see this one, we cancel this part, and if we do the calculations, we got this in second, which is around 358. So around 358 second, that would be the answer. So if you want to convert it into the minute, so we just divide by the 60, and we get the answer into the minute. So if 358 divided by 60, so it is around the 6 minutes. So you can say about 6 minutes is required, around the 6 minutes, okay, to heat the pot as well as the water to reach a temperature from 15 to the 95. So answer for this case is this one. The time required to reach with the given heating elements and the energy, it is 358 seconds. Thank you.